Hey guys, so for today, we are going to be looking at the Newton's second law. Alright, before we move on to this question specifically, let me just explain to you guys what does the Newton's second law states. Okay, now for today, we are going to be learning Newton's second law. Alright, Newton's second law, initially, Newton's second law states that the rate of change of linear momentum of a moving body is proportional to the resultant force and is in the same direction as the force acting on it. Okay, so initially, it states F is proportional to the change in momentum change over change of time. Okay, that is what it states. Okay, but the important part that we are going to learn in our syllabus is that Newton's second law of motion restates that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Okay, senang nak cakap, basically acceleration is directly proportional to its net force and inversely proportional to its mass. Okay, paling senang nak cakap adalah net force atau total force equals to ma. Okay, F equals to ma is basically what we're going to learn in Newton's second law. Remember, it's a vector quantity. All right, without wasting time, let's go on with the question in order for us to understand how does this Newton's second law work. Okay, now, you guys dah dapat soalan macam ni, ini bentuk gambar aja. Tapi jangan lupa apa-apa soalan pun kena ada free body diagram. Okay, in order for you guys to answer the questions properly. Okay, now let's have a go and have a look at the question first. Three wooden blocks, okay, we are talking about three different wooden blocks connected by a rope. Okay, kalau ada rope, ada apa? Tension force automatically has to click in your mind. Of negligible mass, which means we won't be emphasizing on the mass, but don't straight away assume. Tengok soalan dulu. Are being dragged by a horizontal force. Okay. Suppose that force is 1000 Newton, mass 1 is 3 kilos. You guys tahu F equals to ma kan? So mass sudah ada. So I think it's very obvious you have to find the acceleration. Sebab force equals to mass times acceleration. Okay. Mass 1 settle. Mass 2, 15 kilo settle. Mass 3, 30 kilo settle. Alright, before we move on, check on it whether it's on SI unit. Yes, it's in Newton, it's in kilogram, kilogram, kilogram. Okay, settle. Determine A, the acceleration of blocks system, B, the tension of the rope T1 and T2. Okay, this is a very important point. Neglect the friction between the floor and the wooden blocks. This literally means tiada frictional force. Okay, no usage of frictional force. The moment they say neglect. Okay, this is number one. Atau number dua, dia boleh cakap smooth floor. When they say it's smooth, automatically no frictional force. Okay, that is the points that you guys need to know. Next, you guys also need to know this one, the acceleration of the block system. Okay, remember, kalau acceleration untuk a system, this is called a system. Tengok, everything is connected with the rope, right? This whole thing is a system, which literally means acceleration dia satu sahaja. Kalau ditanya separate acceleration of different systems, baru you boleh kena cari one by one. Here, this whole thing is represented by a system, which literally means satu acceleration sahaja. Very important point because these are all the concepts and important ideas for you guys to answer your US or ujian sumatif yang akan datang. Okay? Alright. Now, let's draw a free body diagram. Okay. For M1, okay, this is the object. Force is moving to the left. Okay. Acceleration dia pergi mana? Kalau force dia ke kiri, acceleration pun ke kiri kan? Sebab this is external force. Okay, ke kiri. So acceleration ke kiri. Don't forget normal force. Don't forget your weight force. And don't forget your tensional force. Tensional force belah kanan, always away from the object. Okay, sebab rope dia dekat sini. Okay, now this is the first one. For M2, same thing, normal force, okay, weight force. Okay, untuk M2, ada belah kiri rope, ada belah kanan rope. So everything must be rope to the left and rope to the right. Remember to label which is T1, which is T2. Okay, now for M3, normal force, weight force, ini paling senang. Normal force, weight force. The moment it touches something, there's normal force. The moment there is an object, there is weight force. Okay, next, towards your left is your T2 because it's away from the object. Okay, these are all your free body diagrams for you guys to take note. Okay, now, ada teknik untuk jawab. Okay, everything, my tips over here is everything follow the direction of force. Okay, when you see the acceleration is towards the left, automatically anything which is left and upwards will be positive, anything which is down and rightwards will be negative. Anything opposes the motion of a force, of an acceleration, will be negative. Okay, belah sini, it's to the left, right? So automatically your force will be positive, your tension will be negative. Okay, because the object is supposed to move, everything is supposed to move to the left. All right. Okay, these are the key points. Okay. Now, that is number one. Number two, as you guys know, kita boleh buat table of forces. Just do a quick table of forces for you guys too. Here will be force, X component, Y component. Okay. You guys have to do one by one. Normal force, weight force, external force, tension 1. Don't forget to label tension 1. Okay, remember, whatever which is following the force, whatever which is following the acceleration will be positive. See, acceleration is towards the left. Tension ni towards the right kan, automatically akan jadi negative. Okay. I am going to skip the table of forces, but you guys have to do the table of forces in order to show me how does the value come and which is positive, which is negative. I'm going to skip straight towards the working solution. Okay. For you guys to do, you guys know dekat bawah table kan akan jadi Fx and Fy. Okay. Kali ni, you guys must see over here, the acceleration is in the X component kan. See, it's moving left. Kalau dia move downwards atau upwards, itu Y component, right? Kalau dia move left or right, it's in the X component. So, what you guys need to do, at the bottom of your table of forces, okay, sini X, sini Y, sini force. Okay, you guys will have normal, weight, external force, tensional force. Okay, so over here, you guys will have total force. Total force, the moment it is moving atau acceleration pada X component, you guys must put MA. Kenapa? Newton's second law states that force equals to mass times acceleration. This is the rule that you guys are using. Automatically, Y component equals to kosong. That is when you can come up with equations. This one tambah this one tambah this one tambah this one equals to MA. Equation number 1. This one tambah this one tambah this one tambah this one equals to 0. Equation number 2. So, what do you need to do? You literally need to be doing one by one for every single free body diagram in order to get acceleration. Okay, now, let me show you guys the working solution in order to do that. Okay, for the first free body diagram, your total of Fx will be equals to F minus T1 equals to M1A. Remember, mass pun asing-asing, bukan satu. Next, total of Fx equals to force diberi 1000 minus T1 equals to mass adalah 3 kilo, 3A. So T1 tambah 3A equals to 1000. This will be your first equation from your first free body diagram. Okay, you guys know very well yang ini movement across the x-axis. So try to focus on the total of forces on the x-axis dahulu. Okay, for your second free body diagram, it will be total of Fx equals to T1 minus T2 equals to M2A. Total of fx equals to t1 minus t2 equals to 15a. t1 minus t2 equals to 15a. This will be your second free body diagram. That is your second equation. For your third one, total of fx equals to t2 equals to m2a. Semua ada ma ya, don't forget, because Newton's second law states that total of forces equals to mass times acceleration. So T2 equals to mass adalah 30, 30A. This will be your third equation. Now, first equation ada, second equation ada, third equation ada. Can you guys do your simultaneous equation? Yes, you can do substitution or cancellation method. Get your value of A. Over here, your value of A will be 20.8 meter per second square. Please show me your working steps. Alright? Okay, now. That is for the first question. First question settled. Kenapa satu acceleration je? Because this whole thing is represented by a system. It's connected to the rope. Next, the tension of the rope T1 and T2. Alright guys, over just now, kita dah ada equations, right? So the moment we have equations, you guys will get the answer of A. Can you guys substitute over here? A. I think you guys can substitute over there to get what is the value of your T1 and T2. So for your answers, after substitution your value of A, you'll be getting T1 equals to 936 Newton and T2 will be equals to 624 Newton. Alright guys? Okay, now before I end this session, I would like to give you guys some tips on answering questions regarding Newton's second law. Number one, remember for your free body diagram. Number two, units, change it to SI. Number three, identify which direction is your acceleration and fill it in according to component. Component tu maksud apa? X or Y component. Identify belah mana direction. Kalau belah kiri, maksud dia X component apa-apa yang belah kiri positif, apa-apa yang belah kanan negatif. Okay? Kalau Y component, let's say acceleration downwards, whatever going downwards positive, whatever ikut acceleration akan jadi positive, whatever opposite of acceleration will be negative. Alright? Okay. Next, number three, remember you can come up with equations. Okay. Now, those are the tips for this kind of questions. Alright guys, I hope you guys enjoyed this session and I hope you guys could do and understand well what does the Newton's second law actually states and how to apply them into calculations. Just simple method and simple understanding of F equals to ma. Alright, note where the acceleration goes and total force equals to mass times acceleration. Okay, I hope you guys enjoyed this session. Thank you very much. Happy study guys.